So hey, hello guys, how are you? Hope you are fine. So our today video is about sets, its operations and Venn diagrams. So let's start our video by our presentation. Today we are going to discuss these topics that I have written there: Venn diagrams, operation on sets, and practical problems on these operations, which are union and intersection of sets. So let's start our video without any delay. So here we will first discuss about Venn diagrams. So basically, what are Venn diagram? There is a basic definition of Venn diagram. It is a pictorial representation of sets in which a set is represented by a circle or a closed geometrical figure inside a universal set, which is shown by a rectangle. Like I will show you by making it. We have this universal set and we will show this by a rectangle, and any set A is shown by a circle or a closed figure. Basically we use general we use circle to represent set, or you can also use triangle or any closed figure, but that should be closed figure, a polygon you can see. And now what is a complement of a set? We have discussed here in the first point that any closed figure in universal set is called a set. So now basically, what is complement of a set? So complement of a set is the region which is left behind after we make a set. So this is a set A and this is a universal set. So what is this region called, which the element present in this region are not present in set A? So this region containing those all elements which are not present in A is known as complement of set A. So this is what we have called complement of a set. Now we would discuss intersection and union of set. We will discuss it in detail later on, but I will tell you only some basic thing, that when we make two sets and there is common element, there are common elements in them, this region is known as intersection of sets, and the all elements present in both A and B is known as union of these two sets A and B. Now basically, what is the use of this Venn diagram? Why we make them? We can easily solve Venn diagram. We can easily solve problems on set theory by theoretical part, but these Venn diagrams are very useful when we have problems on intersection and union of sets and number of element, when we have to find number of element in any set, and when we have 2, 3 or 4 sets, and there are many set 3, 4 sets, and we have to find out the solution. So we use them Venn diagram, because they will confuse us very much, and we maybe lose our time, and our exam will be left. So we make this Venn diagram so that we can find our solution very easily. They are very helpful. So this is all that we have to discuss in Venn diagram, and there is a note for us that when we are making Venn diagram, we have some basic things there. When two sets are disjoint, when A and B are disjoint sets are those sets which do not have any common part. So basically, when two sets are disjoint, we show them by making two separate circles. It is only basic point. These you can see there. These are only basic point I am telling you. And when one set is subset of another, it is shown in another set, because you know very well that one set is subset of other. The superset of that subset contain all the element present in that subset. So that's why we show the subset of any set in itself. So these are basic steps while making a Venn diagram. Now here you can see some Venn diagrams that I have found, and firstly you have seen there that P and Q are disjoint, and their Venn diagram is like that, where P is containing 0, 1, 2, 3, 4 element, and Q is carrying 8, 9, 10 element. They don't have any element in common, that's why they are shown separately, what I have tell you in the before slide. And the next diagram is of union and intersection of set. In this set A and B, you can see that 153 is in both elements, in both sets. So 153 will be the intersection of these two sets A and B, and union of these two sets will be all the elements. But please take care while solving union, that 153 will be counted only one time. You should not write in union that in the union of these sets contain 9, 7, 1, 5, 3, 1, 5, 3, 4, 2, because these are the intersection should be counted only one time while we are counting union of two sets. So this is a basic thing I have told you. So now operations on set. That is our next topic. So operation, basically we perform three operations on set. First is union of set, second is intersection of set, and third is difference of set. So let's see what are these operations. So firstly we have their union of sets. So union of sets, the definition of union of sets, I have explained. It's short, it is short before, and now we will discuss it in detail. The union of two sets A and B, denoted by A union B, is set of all elements which are in A, B, or both A and B, and this is represented in symbol. The symbol I have, this is in this is in set builder form. So I will tell you, A union B is equal to X, where X belongs to A or X belong to B. So union is basically or, represented by or. Meaning of or is that the A union B will be any element present in A, or it is any element present in B. So in simple words you can say that A plus B, elements in A, elements plus elements in B, are known as A union B. But the note that we have to note there, the thing which is very important, that the elements in intersection, we should not count them two times. And when the sets are disjoint, then it is simple, it is very simple. The union will be A plus B. So we have their example: if A is equal to 1 3 5 7 and B is equal to 1 2 4 6 7, then A union B is equal to 1 2 3 4 5 6 7. And here you can also notice that there is intersection in these sets 7 7, and also yes, 1 and 1. So we have taken 1 and 7 only one time. So this thing you have to notice very well, guys. So our next operation is intersection of sets. So intersection of sets is in the intersection of two sets is A and B, denoted by A intersection B, is the set of all objects that are member of both sets A and B. In symbols, A intersection B is equal to X, X belong to A, and X belong to B. It means that that X will be common in both sets. The common, this is in simple words, the elements which are common in both sets are known as intersection of sets. And here we have an example. When there is intersection of two sets, A, that is 1 2 3, and B 2 3 4, 2 3 2 3 elements are in both sets, and they are common. So the intersection will have elements 2 and 3. So this is intersection of sets we have discussed in now. And now let's move to difference of two sets. The difference of two sets is mainly A minus B. You have no very well difference when we do difference of, so it will be A minus B. But there is a note in this set. When we do difference of A minus B, we also have to take the elements in the intersection in A, but we will not consider in B, because these elements are also present in A. Here you can see that 11 13 15 12 and 14 are present in A, but 12 or 14 are also present in B. So you will say that 12 or 14 is also present in B. So why have you removed them from A? Because these elements are also present in A. Here you can see that X belong in the definition of difference of A minus B. A minus B is equal to where X belong to A, but not does not belong to B. That it should not be belong to B. So when A is equal to 7 8 9 10 and B is equal to 7 8, then A minus B is equal to 9 10. We should not write the elements that are present in B in A. We should only consider 13 11 and 15 when we do A minus B. This diagram of B minus A, that's why there is written that 10 16 and 18. But when we will do A minus B, we will always consider only 13 15 and 11. And this is the representation in terms of intersection of A minus B. A minus B equals to A intersection B complement. This is very main formula which we have to use, that when we have A minus B, so B complement is basically what the all elements present rather than B, and its intersection with A, like it's B complement, and A is common part. So this part is only A minus B. So that's why there is formula that A minus B equals to A intersection B complement. Now we have discussed this operation, so let's do some exercise so that we will. So firstly we have this question where A, so let's read our question first. If C is equal to set C is equal to A B X Y and set D is equal to M N O P, then C union D. Now we have to do union, and while doing union, firstly we have to check that if there is any intersection between them. But here you can see that these sets are disjoint. Why these are disjoint, you can see there clearly. Set C has elements A, B, X, Y, and D have M and O, B. There are no common element, so that's why these are disjoint. So we will simply do A plus B, and these are, and this, so this is will be the right answer, because this contain all elements present in A and B. Here you can see A, B, X, Y, M, N, O, P. These all elements are present in C and D. You can see. So I have told you this in, for when there set, when two sets are disjoint, then we would use this formula A plus B is equal to A union B. But this will only work if two sets are disjoint. So you have to keep this thing in your mind. So our next question is, when A equals to, here you can see, let's read the question first. When A equals to 2, 3, 4, 5 and B is equal to C, D, E, F and C equals to 4, 5, 6, 7. Here you can see we have three sets. So firstly we have to do A union B, then we have to do C union D, A union C. You can see there very well that A union B is equal to 5. Why it is 5? You can see there that A has element 2, 3, 4, 5, but we have C, D, E, F in B, and these are alphabets and these are numeric values, so there is no common between them. So A union B will be 5. 5 meaning nothing, null set. You should know about this. If you have discussed, we have read it in detail before doing operations on set. So A union B will be null, and null intersection A union C is also null, because null set and any intersection with any set, if it will be universal set or anything, would be null set. It will be this, because when we do any intersection with null set, intersection is what? It is basically common part, and common part between null set has nothing element, it has nothing. And if any set contain any element, it may be 1, 2, 3, 4 or anything, their intersection will only be null set, because null set does not have any of these elements. So that's why there, it is very easy question. But some people may get confused in that why its answer is none of these, because you can see here directly that A union B intersection A union C is there, and A union B does not have any single element in common. If we would do this A union B, then it will be, here I have some mistake in my question. Okay, sorry, I have written there wrong. This question is A intersection B intersection A intersection C. This I have to write. I have written by mistake, that is A union B intersection A union C. This is question, then answer will be none of this. But if we would discuss that I have written, let us solve the wrong question also that I have written. When A union B intersection A union C is there. So in this question I have one, we will simply add them because A and B are disjoint. So its answer will be 2, 3, 4, 5 C, D, E, F. So A union B will be 2, 3, 4, 5 C, D, E, F. So it is answer of A union B. Now we have to do its intersection with A union C. Now what is A union C? A union C we have to find. A union C is 2, 3, 4, 5, 4, 5, 6, 7. The note we have also discussed that 4, 5 will be counted only one time. So its A union C answer will be 2, 3, 4, 5, 6, 7. So here we write 2, 3, 4, 5, 6, 7. Now we have to do this intersection. It means that we have to find their common part. So their common part you can see clearly. The 2, 3, 4, 5, 2, 3, 4, 5 are present in both sets. Here you can see 2, 3, 4, 5, and here also 2, 3, 4, 5 present in, and these parts are not included in their common. So in their intersection will be 2, 3, 4, 5. So answer will be option B. This will be the right answer. This is also very simple question. You have to only firstly solve, firstly we have to see that if they are disjoint or not. If they are disjoint, then you do not have to think very much, just add them, A plus B, and here we can do this very easily. You don't have to consume any time. This question is very easily. So hope you liked my video. Please like, share and subscribe. And a special thanks to our maths teacher, Mrs. Rekha Oja. Thank you guys. Hope you will like my video.